Okay, welcome everyone to our third community call about topology protocol. Let's get it started. Yay, so agenda today would be one, we're releasing our white paper for the protocol, and two, we will be giving updates on the development of the protocol. So the white paper is released. You can find the paper at paper.topology.gg. You can also take a look at the drafts in the past and the revisions, which will be tracked at this GitHub repo, Topology Foundation/paper. Okay, so this is the white paper, and for those of you who have checked our past drafts, such as version 7.x, this version is quite different. It has more content and it has more considerations in different areas of the protocol. So we hope that you will look into the paper if you're curious. And for now, I think it's good to give everyone a friendly reminder and a quick introduction of what the protocol is about. So here we go. CRDT, we won't be diving into what it is right now, but we have an Ask Me Anything session later, so we can do that. If you know what CRDT is, what we're essentially doing is we are creating a new abstraction called CRO, where O stands for object. So it is an object that leverages the magic, the properties of CRDT. One way to think about this is the following. So on the left side, you have the World Wide Web, where which everyone uses nowadays, where every website is basically constructed as an HTML and is accessible via the HTTP protocol. So from this mental model, we can look at topology protocol, where CRO is the object or is the material that you use to make applications under this protocol. And topology protocol is the protocol that you use to interact with CROs. Similar to how on the web you use HTTP to interact or to request content from HTML sites. Okay, here we go. A quick overview of the white paper, chapter by chapter, very quickly, but at least it gives you a rundown of the entire paper. So introduction section introduces the entire contribution of the white paper. CRDT section gives you a very brief introduction of what CRDT is to set the stage. Chapter 3, you have section 3, you have CRO, which introduces the abstraction that we proposed, followed by section 4, causal ordering. Everyone here more or less understands how blockchain works. Most blockchains uses total ordering. So causal ordering may be a little bit unfamiliar for some of you. So this will be an interesting section to you.
What's total ordering? What's the difference
total
between
ordering?
total ordering? Yeah.
Yeah, okay, good question. So total ordering. Total ordering means you take any two events in your system and you're guaranteed one event is going to happen before or after the other. There's no ambiguity. It's either, if you take any two events, it's going to be either A happen before B or B happen before A, period. That's total ordering. So on a blockchain, every block forms a chain in a before-after relation. And also inside each block, you have a list of transactions that is ordered in a total order. So if you don't look at the block boundary, then essentially on a blockchain, every event that ever happened on the blockchain forms a timeline. Everyone sits on the same line, so they can always be ordered. That's your total ordering. Causal ordering is different because causal here is related to causality, right? Cause and effect. And we know in our world that sometimes something are not causally related. Sometimes some events, they're just not causally related. They happen at the same time. They happen independently. They don't have causal cause and effect relationship between them. So in a causal order system, not every 2 events can be ordered. You would have events that simply cannot be ordered, but they're independent and they happen at the same time or concurrently. And that is the ordering that we are using, and that is the reason why our system is able to be much more responsive and much more available. Is because we embrace the concept of causally independent events or concurrent events, which the blockchain system doesn't recognize at all. So that's causal ordering. We hope that the section will give you a better overview of what this means, and specifically, hashgraph is the construct that we use to enforce causal ordering. On the right is a hashgraph. This is copied from the white paper directly, and I don't think we need to go through the diagram here without all the rest of the context. But hope this will pique your curiosity. Following hashgraph is concurrency semantics, another very important thing for causal ordering. Concurrency semantics basically means that if you have events that happen at the same time, then how do you handle that? How do you incorporate those information to change the state of your program? That is called concurrency semantics. It's the meaning of things happen concurrently. Okay, section 5 gives you signaling. Signaling is how CRO talk to each other. And section 6 gives you invariants. And invariants are things in your program that should always be true. These are predicates that should always be true. So for example, for the cryptocurrency program, you would have the invariant that no account should below 0 at any time. Like all account balances should be non-negative at all times. That is your invariant for a proper cryptocurrency program. And different programs and different applications would have different kinds of invariants. The reason why it deserves its own section is because in the realm of CRDT, or to be more precise, in eventual consistency land, some invariants are tricky to preserve. So we offer some approaches and solutions to enforce some tricky invariants in section 6. Section 7 gives you 2 examples. So they offer you pseudocode of a CRO that implements some application or some use cases. To be specific, the first example gives you a social graph. That is, you can imagine this as a super simplified version of the forecaster social graph. Okay, and the second example gives you a multiplayer physics simulation. So essentially, it is a simulation of many players, each one controlling an object, and they can collide and they can interact with each other in a simulation. So this basically is the sort of the fundamentals of a modern video games, where you have a physics engine that simulates objects and their interaction. So we hope that the first one would demonstrate the potential of CRO for social network, and the second example would demonstrate the potential for CRO to power multiplayer games, lobbies, and trending towards Open Metaverse, which is the goal of the entire protocol, is to be the distributed system protocol for the Open Metaverse. Section 8 gives you interaction methods. So this actually corresponds to HTTP, where you have different request methods, right? Put requests and get requests. For topology protocol, we define for now a set of basic methods, including create, update, subscribe, unsubscribe, and synchronize. So these are the set of 5 basic methods you can use to interact and with the CRO. Following that is section 9, operation lifecycle. This is a very short section, but it tries to explain the lifecycle of an operation of a CRO, in contrast to a typical transaction on a blockchain. So hope that this section would explain how CRO behaves differently from a smart contracts on a blockchain, for example. Section 10 and 11 are so-called advanced features or advanced considerations of a CRO. So section 10 gives you snapshot. A snapshot is the ability to take a picture of the CRO state. And this is trickier than it seems, because with a CRO, you have many people potentially concurrently editing it. And so taking a snapshot means that you need to have some sort of agreement among all these people of the same CRO of what the state is of the CRO. So that is a snapshot problem. Section 11 gives you compaction. Compaction is the idea that the history of these programs are grow only, and in a similar way that you can say blockchain is a append only log. So when you have a grow only log of events or grow only history, it's not good because it requires boundless memory to store, and it can cause memory leak. It can slow down your program over time. Grow only structures are not great for sustainability. So compaction is the idea that, hey, can we prune the history from time to time, knowing that the past is no longer useful, or knowing that we have to prune it and move on anyways. We can't keep all the rest of the history at all times. Next section gives you access control, and access control is important practically because you can't have all programs that are publicly accessible by everyone at all times. For community programs, you want in-group having special access that's different from out-group people. So access control is a practical consideration for CROs to be useful. Section 13 gives you security. So we discussed 3 different threat models that can make CRO unsecure and possible solutions to those threat models. The next section gives you decentralized RAM. So we have this idea that this entire P2P network implementing the topology protocol, whatever language they are implemented in, as long as they follow the spec, they form a P2P network. And this P2P network has certain properties that make it behave like a random access memory, as opposed to blockchain, which to us seem more like hard disks and hard drives that are persistent and non-volatile memory. Whereas the kind of P2P network that our protocol enables is eventually consistent, is ephemeral, is local first, and is very responsive. So it resembles the property of a RAM in a computer architecture. Followed by conclusion, the last section. So hopefully this rundown gives you a brief idea of what to expect when you eventually start to read the white paper, and we would love to hear your thoughts. Okay, this is a transition slide. So the protocol that we are working on has many layers and many components, and we are tackling the core components of the protocol right now to be able to give developers CROs that are useful to build applications with. So we transition to updates on the development.
Okay.
Are we taking questions, or Oak, you can start?
Yeah, we can take questions now.
Anytime. I can't see the chat, so
no,
interrupt
because
me anytime.
usually people just post questions on the chat. Today they are shy. Today they don't have questions for you. Is everyone shy today? Usually one of our question master is Kono, actually, which is part of the team, so it's really funny. But now we have some people. Yeah, no, everyone is just saying that they are listening.
Yeah, that's good.
Yeah, but if you have any questions, you can just drop them in the chat, and we are more than happy to answer them. Also, just a reminder, reminder now in the middle, that if you want to talk about something that might be related with the topology protocol, we more than welcome you to come on stage and speak about it. We usually put it in the agenda if you tell us in advance, but if we have time in the end of all the community calls, we can also make space for you to speak. So if for this community call, if you want to say something in the end, you can just drop some message in the chat and we can totally talk about it. Now we have a question for Kono. Kono got shed because I told that. How did you guys come up with the protocol as it is now? GG.
You want me to go? Do you want to offer? Yeah, your thoughts.
I think I can go with my thoughts, but I think yours are way more useful because the protocol, the origins of the protocol, it came out from you in the past. The thing is, I joined more in the middle and I gave the inputs for it as it is now. But in the past, the origins of it was more you. Then that's why I think it makes more sense on you speaking about it, and then I can just add my opinions on it.
Yeah, sure. This is a pretty big question. How did we arrive at the protocol or come up with the protocol? Yeah, I there's an impulse in me to pull up another slide and go through the history of topology. It's like a 50 slide presentation.
No, it needs to be a super shortened answer.
Yeah, I think long story short is this. Okay, so let's try to do a pitch here. So we believe in the open metaverse being the next iteration of the internet. It has to be more free. It has to be more flexible. It has to be where people hang out and deploy richer programs, richer kinds of applications, and be able to collaborate with way more productivity and agency than everything we have right now. So it is the next iteration, and we believe further that it has to be on open decentralized networks. So it cannot happen across a federation of big companies and their systems as is. It has to be built from a grassroots perspective, and it has to be very decentralized. At least in the beginning. Maybe there's this dynamics of going between centralization and decentralization, as we know from the history. But at least in this new era, in the beginning, should start from this decentralization route. And so 3 years ago, when we started the project, we thought, okay, blockchain is great because it allows you to program and run programs across PDP networks. And we are talking about replicated state machines over Byzantine consensus. How typical blockchain provides programmability nowadays. The problem is after a year and a half, after many experimental games that are running fully on the blockchain and verifiable VM and so on, we recognize that blockchain's bottleneck is in its strict consistency, and we don't believe the future of multi-user software on the internet should be running over strict consistency, where every event is ordered in a linear timeline, in a total ordering fashion. So we're looking for different constructs that are way faster, but it also has to be running over PDP network, which means you can't give God power to a single server for it to work. And it has to be tolerant to Byzantine vaults. Otherwise, you will have restrictions on what kind of clients you need to run the system with, which makes it not decentralized enough. And we stumbled upon CRDT. So there's a paper published November 2022. Title is Byzantine Fault Tolerance CRDT by Martin Kleppmann. I think even taking a step back from there, we talked to our friend June, who is maybe not in the call now, but our friend June listened to our misery, building everything on chain, and he said maybe you should look into CRDT. By then, we were looking at multi-party state channel papers, and he said maybe CRDT is something that you will be interested in. And that very day when we took the call, we looked into CRDT. We found the paper on BFT CRDT, and we knew that our future is going to be building on top of this construct. And this was 2023, April 2023. We're more than a year further. And so it was a very long journey of looking at CRDTs, and CRDTs traditionally are not running over PDP networks. They traditionally are used for scaling and building your distributed database services and web apps for collaboration use cases. But we're trying to come up with a P2P protocol using these constructs to provide programmability to anyone who wants to build multi-user software that is very responsive and owned by the users with sovereignty and so on. So it's a very long journey. And Oak, I think we started to collaborate last winter, between autumn and winter, where you started to give a whole bunch of feedback. And it was very fortunate because we ran into you, and you came from a university where P2P epidemic broadcast algorithms and CRDTs were partially invented there. So
yeah, that's right. So one of the co-authors of the CRDT papers is a professor in the university that I came from, and also most of the research on peer-to-peer networks and optimizations, not much DHTs, but more about gossip protocols and all that. Most of the papers were also written by one other professor from my university. Yeah, so that from my point of view, since I arrived a bit late, the part of the protocol as it is now, when I joined, everyone here already had lots of ideas and points of views on what we wanted to build as topology protocol and how we wanted to build. And then, as it is now, it was basically lots of feedback that we had from external people, and also feedback from people that have been joining us since then. And it was been super useful. We have lots of questions now. So we didn't have any. Now we have like one, two, three, four questions. I'm going to drop the ones that the topology team did right now, and just going with the external people questions. And the first is from my Celia. I don't know if I'm pronouncing the name correctly. And basically, it's, if I wanted to gamble, what are the meaningful differences between building the app on chain versus with CRO? And that question, it's actually quite tricky, because when you are doing gambling, you are in a super competitive system that you also want to have some secret factors in it. So the thing here, I don't think it's much on-chain versus CROs. It's a lot based on cryptography, and the thing is that's the whole thing that I highlight how ZK and why ZK is super useful and why ZK is super important. And basically, is exactly that: is you communicating with other people. Because currently, if you want to gamble, what you do in current systems is you go through a centralized server, and you have an algorithm that is implemented by most casinos online that ensures that you have some randomness there. And the thing is, you just need to verify that that randomness was not broken. The thing is, you trust that central server to do all those operations with the randomness. And the thing about on-chain versus CROs is you need to have that implemented in either. So if you have that implemented in either, both are going to work more or less the same, I would guess. Here, but my knowledge on that is pretty limited. So this is the point where people might need to fact check me and give better opinions on it. And we have lots of smart people today in our community also. If anyone thinks that I'm saying something that is totally wrong, you can just hop on the chat and say, "Yo, Oak, you are totally wrong. It's not like that. It's like this." And then we also have one question from Tianyu. If one CRO is compromised, will it crash the system security? And that I can also answer that one, actually. Here it means it depends a lot by what you mean that CRO is compromised, because CROs as they are, they can be compared with smart contracts. The thing is, if one smart contract is compromised, no, the other smart contracts are totally fine. If Ethereum is compromised, yeah, then maybe all the smart contracts are compromised. So here, if one CRO is compromised, the answer is no. It's independent of the other ones. You don't care about it. But here it depends a lot on what you are you also saying about talking about within the system security. So here for having a good answer here, we need a way more detailed question on what do you mean by one CRO being compromised? Is what is the code that built the CRO is vulnerable and someone breaks it? And what do you mean also by system security? Because if it's the old topology system, yeah, it won't break because one of the CROs. It's not unmuted. You need to come on stage to speak. But the thing is, then let's do the opposite. Let's have ask me anything by the end of this CC, and we just answer the pending questions here. We also have a new question from Anderson Chat. We ask all of them. We answer all of them on the end of the CC, and a part of that you can also come on stage if you want to clarify more the questions and have an ongoing chat. I think that way is better. So maybe we should go ahead for the engineering updates. Yeah. So engineering. So this slide is pretty similar with the one that we had 2 weeks ago. And mainly is we've been doing lots of work during the past 2 weeks. We are still doing the protobuf and WASM implementations. We have been collaborating with lots of people to get those features ready and done correctly. We are almost integrating the protobuf and WASM ones. That one also comes with a super big refactor on the whole code base because some of the ways that we were interacting in the past were not that good. They were highly demo driven, so there were lots of things that were not pretty nor good to interact with. So we are doing updates on that. WASM is becoming really tricky. We might have intermediary version of WASM is not working perfectly, but it's already within the code base, and then do a new version where WASM works better. We've been receiving lots of help from Kiwi. Kiwi also, today we merged a PR from him, so we have a new contributor to our code base. And he's been helping a lot with WASM. If anyone here knows lots about AssemblyScript, please let us know, because we are having lots of things that we are considering and thinking about, and the more feedback we have on it, the better. Then I'm talking about first about the things that we are working on, and I skipped a bit the things that we already done in the past 2 weeks. Hash graphs, it's something that we already have also PR for it. It's being reviewed right now, the initial version of hash graphs. And this one, I actually want to, so we have someone on our team that did the whole implementation for this, and I think he should really introduce hash graphs, because it's the way that our conversations on how to implement it and what should be the approaches are super interesting, and I think since he implemented it, he can give us a bit more things to speak about. But I'll just go over all the development updates, and then I'll give him the floor. Part of that, we've been working a lot on documentation. We want to have this ready by the beginning of next month. We already have a new version of the docs page, although it's still not complete nor super good nor perfect, but we are working on it. On those documentations, we talk a lot about about the protocol, about the CROs, about the CRETs, about hash graphs. So, but our explanations that are supposed to be way simpler than the theoretic ones that we have within the paper. But if you want to have all the super technical details, I think you should totally go for the paper and not just the doc. A part of that, we are also working on the specs. The specs here we are not progressing that much on that one, and the main reason is because we are focusing a lot on the first three, the protocol, the Wasm, the Ashgraph. As soon as we have those ones finished, we are focusing way more on the specs, because specs, on our perspective, it's for us to define a lot on how the protocol works within the code that we currently have. And the thing is, most of the features that we want to have within the specs, we don't have them in the code base yet in the main branch. And that's why we are waiting on those PRs to be merged first before we continue working on the specs. The things that we have done and have merged for the past 2 weeks, we have a new built-in for a CRDT, and we added also logging. The tricky part here about logging is that PR was just reverted today. So the documentation and the logging has been done by 2 people that are working with us. We have two interns. They are in the call. It's Jan and João. And they've been doing an amazing job. The thing about logging, it's pretty good. It's already implemented and all that. But we had some limitations on the way that we were visualizing stuff, and also some limitations on the library that we are using. The library is TSLog for your information. And since we're having some limitations and some bottlenecks that got our debugging speed worse, we reverted the PR. The thing is, we are investigating right now on how to improve those things those bottlenecks that we found. And as soon as we have them, we are going to re-merge that PR. And mainly that's it for the updates for engineering. And I think Akash, you should come on stage now to give us a big intro on the Ashgraph's implementation and our approach.
So this week we made a draft implementation of the hash graph. So the hash graph is like it encodes the causal ordering of all the operations occurred in the CROs. So the current implementation, like the API is super basic. We have a method to add a vertex to the tag, to the hash graph, and then we have a method to linearize the whole hash graph from the initial vertex till the last one. So for that, what we are doing is computing the topological sorted order of the whole hash graph, and after computing that, we are pairwise comparing each of the vertices in that ordered array to check for causality, concurrent conflicts, and only if any two vertices are causally dependent, only then we try to resolve their concurrency. So everything is like now the implementation is super basic. It's not very efficient, I would say. So we are looking into more optimized approaches, like using LCAs to speed up the linearized operation. Yeah, and also like the current code base, we haven't considered a multi-threaded scenario where there are multiple workers listening to the peer-to-peer network and attaching new vertices to the hash graph. So that is something we'll explore more this week and next week. And also keeping in mind a good developer experience for the CRO, we need to make changes to the Azure API.
Yeah, we also have, so one super nice thing on that PR is that we also have actually extensive testing on some tricky hash graphs that we thought about and how our algorithm behaves when we have those weird hash graphs. So that's actually something that also is super cool that Akash implemented. I think that's mainly it for the latest development updates. Does anyone have any questions? Do we have any super expert on assembly script that is going to help us out figuring out everything that we are missing on WASM? So if you want, I can extend a bit more on what is our current bottleneck with WASM and the assembly script. And basically, so for topology protocol, the main thing that we are aiming is for developer experience. So we want everyone to build CROs in a super seamless way. And the thing is, one thing that we have to make it working is that the CROs need to be propagated on the network, and they need to work with different computers and different machines and different client implementations. And for that, we need to have some runtime that is compatible with all of them. And the most famous nowadays runtime that is interoperable to every place is WASM. And the main client that we are currently developing is the TypeScript one, because we need to have browser integrations and browser demos and all that. And we want to enable people to use to compile to create CROs within TypeScript and compile them and send them to the network. And for that, there is something that is AssemblyScript. The thing is, AssemblyScript needs to compile the whole file, and AssemblyScript is something that is pretty similar with TypeScript, but it's not one-to-one compatible. So there are some structures that they might have the same functions, but even the function signature is different. So the inputs that the function is expecting is different. So at the same time, sometimes you can't have a function that is implemented that it's going to work in AssemblyScript and TypeScript. And the tricky thing here is that for us to have a super seamless experience, we need to compile that file instead of other people, the CRO developers compiling that file. We need to compile them within our library, and that's possible to do it. We already did some proof of concepts, and it works kind of fine. The tricky thing is when we are bundling when a CRO dev is bundling their build, lots of dependencies are lost in between. And the thing is, we need to have those dependencies as they are with a local path that is somewhat structured, and we need to have all our CRD built-ins there. And AssemblyScript with other package managers are not helping us out at all with that. And to make it work with all package managers is going to be somewhat painful, and we don't want to deal with that because it's going to be something that is going to be hard to maintain. Saying, oh yeah, if you want this to work, you need to put this configuration on Webpack, or you need to put this configuration on Vite, or you need to put that configuration on whatever. And that's something that we don't want to deal at all. So we can do it to the major ones, but then we are reaching some bottlenecks that every time that they release, we need to update all of that. And that's not our main focus. So nowadays we are trying to find a better solution to do it. That's why we probably are going to have an intermediary version where we already have lots of stuff with WASM and lots of functionalities within our code base, but it's not going to be totally complete until we figure out this part. Yeah, that's mainly the development of this. No, I already went over it. So now it's the time for Ask Me Anything. We still have a couple of questions here. I'm just going over Anderson's Chan question first, and then we can give the floor to Tianyu to come on stage and talk a bit more about his question. It seems that it was not fully answered. so does interaction methods mean write-read methods from external world? Are they some APIs or something that can be defined by CRO creators? So here, interaction methods, those interaction methods usually are just handled within the topology protocol. They are not handled by external people. The thing about having the write-read methods from external world is that, so when a CRO creator is developing a CRO, they are developing it with some application in mind, and that's bundled within the application. So all the exports for functions are already there. Then we have another thing that is interactions between CROs, and that you can count that as an external world. And that part is the signaling part. Where is it? It's previous 5, GG? Signaling? It's one section of the paper. It's the section 5 of the paper, where you actually can interact between CROs with some kind of API, but that API is also defined by us. For external software that is not CROs, CRO developers need to create their own API for interacting with their CROs. The thing is, it's not an issue also. Am I saying something wrong, Gigi? Or do you want to add something?
No, it sounds good. I was just picturing, can I make an iOS app for a multiplayer game, and can I put topology node in my iOS app?
Yeah, so that's the super funny thing about mobile, is you don't know until you try it. So iOS, I'm not sure. Android, I know there. So even, do we still have Kiwi here? Yeah, we have. So even Kiwi also worked a lot in actually having peer-to-peer applications running on mobile. So that's something that is totally possible. I think it can give us more feedback if it also worked on iOS or not. But for Android, for sure, you can have that on both.
Yeah.
So iOS, you can also have that. Yeah.
Okay, so the idea is, so in case it works, maybe there are a lot of I think there'll be a lot of complexities we cannot oversee until we work on it. But let's say it works. So imagine, as a game developer, you make a game as an iOS app, and you incorporate a topology node inside your iOS app. You also define your CRL for your game, and then you put it on App Store, right? And then all your gamers download your game to their phone, and they start the app on their phone. Once the app is started on these phones, the nodes that are embedded in the app begin to find each other on a peer-to-peer network, and begin to listen to and basically subscribe or connected to this CRO, which is a virtual object. It doesn't exist anywhere. It exists everywhere on all these gamers' phone, and all these phones are connected, and they can start playing the multiplayer game.
Yeah. And so here, that's a perfect thing to also explain the part of the interaction methods. So all those methods of subscribing to the CRO, creating, it's the CRO dev, the CRO creator that is going to use that in the beginning. But all those update methods, all those sync methods, are methods that are going to work within the topology protocol directly when people are interacting with those CROs. It's not something that people can go through the code base and manually do it, but usually that's not the goal of it. It's just abstracted from the users. The exact same example that Gigi was talking about having multiple iOS devices connecting between each other. If me, as that application developer, say, "Oh yeah, but I don't want actually phones to run nodes. I just want to have the CRO properties. I want to have all the CRO properties within my own servers, and I just want the iOS devices to connect to my server. Then it's responsibility of the CRO developer to create an API that enables the users to interact with the CRO. And the CRO is hosted in the node that is its own server and the other servers that he might deploy. Yes.
Right. So then in that case, you would have nodes that are run by the developers where these gamers are connected to, but nodes don't run on the gamer's phone. Yeah.
Yeah.
I think another thing that maybe...
Go ahead.
Yeah. Oh, I was changing topics, so you can go ahead first.
No. The only thing that I was going to say there is that is architecture designs that application developers are free to use and change and do however they seem that is better for their use cases.
Right. I think one thing about this follow-up is that if you use the approach where nodes are embedded in the applications running on the phone, the idea is that from the developer perspective, you don't need to run servers for your games to be a multiplayer network game. So it's a serverless game, but it's not the kind of serverless that in the cloud computing language, what serverless mean. It's actually, there's no server in the picture, but you can have a multiplayer network application. And that comes with its trade-offs, and both in technical user experience and business implications. But I think to Oak's point, it is a choice to be made by the developers. Another thing that I can bring up is if your application is also distributed to the Google Store, where people download applications to run on their Android phones, you can have cross-platform applications where Apple phones and Google phones are interacting because they run the topology nodes, and topology nodes can interoperate by following the spec and implementing correctly.
Yep. So I think now is the perfect moment to call Tianyu on site. Well, how do I do this? Here. Hello.
Hi. Thanks for the opportunity. But just to clarify my question, maybe in other roles, I'm thinking about, because I'm more about the snapshot part, or for the to take a snapshot of a CRO object. I'm wondering, like, because one CRO project state is only decided by its subscribers, so I'm wondering, like, if one CRO project state is decided by like, I would say, more than half malicious ones, it means like the state of this object is compromised. So as the CRO and this snapshot will be uploaded to the entire blockchain or for the chain. So I'm wondering, like, whether it will influence the entire system security. I guess I wish it is a bit clear, or correct me if I'm understanding something wrong.
There are two points on that question. The first is so we have more than enough people that are bad actors on the network, right? And they say the snapshot version is this. So if you have, so this is a democracy. If you have more than half people saying that that you are wrong, you are wrong. It's a crime.
No.
So
I mean, once CRO maybe it's only decided by its subscribers, so I can have some intentional.
Yeah, it is. No, the thing is, CROs are just it's here it depends a lot, and it's not subscribers, it's by its writers. And the thing is, here is where you mix lots of stuff with the access control also. So if it's a free for all and everyone can write, if you have more than 50% people that are writers and they say that the version is this, then they are right.
Right.
I know that it's not a pretty answer for anyone to hear, but that's actually how most things work. Is that if most people say that you are wrong in theory. You might be still right. We know for sure that majority is not a good thing. But here is where you can also add a threshold and say, yeah, so unless I say that we have a threshold of 2/3 of the writers to do the snapshot. If you have that threshold, you need to have 2/3 of the network being bad actors. And the thing is, if they are, you are wrong. They are right. So there are lots of configurability that you can do here to manage that. When you start having ACLs and you have write controls, just to not to everyone that joins that CRO, but to a more limited amount of the people on the CROs. And the thing here is it also mixes with lots of other stuff. Because you can even also try to do invariant checking before you do the snapshot on chain. So the snapshot gets denied on chain if it breaks invariant. So the writes need to be all valid for it to be, and then it needs to have the proper signatures to do it. And the thing is, if all the writes are valid, it's still right. It's a CRT, so all those operations are going to be there for sure in the future anyway. You can have some kind of DOSs there though, in the sense that you have bad actors that are not signing on purpose. That's one part. The second part is does it break the whole system or the whole system? No, it doesn't, because snapshots are just for each CRO. So CRO snapshots, the mechanism for you to do snapshotting. So that's actually something that we are currently talking about a lot internally on how to do it. But the thing is, the answer is they are not going to depend on each other. So a snapshot of CRO A is totally irrelevant for the snapshot of B. You might have some issues though when you are talking about signaling that might depend on snapshot, which I'm not sure if they are going to be relevant. But Gigi can correct me better on signaling because he has a better image for it.
Yeah, I think is my voice still connected?
Yes.
Okay. I have two thoughts. So one is about the coupling problem. Can one bad snapshot corrupt the rest of the system, or at least some impacting some other parts of the system? Well, I think you can have dependencies outside of the topology protocol. And so, for example, imagine a CRO where the majority of its users decide to do something bad, and it becomes the representative voice from that CRO, which is put in a snapshot and go on some blockchain. Okay, this is fine, it's still confined. But then maybe you have another smart contract that decides to read that snapshot and do something. And then you have another CRO that's reading the state of that smart contract and doing something over there. This is a different CRO. So now you can see a bad snapshot can maybe corrupt the other CRO, but it's only because you have these dependencies between smart contracts, and which is outside of the topology protocol. So I think in the complex systems, you can have a lot of these dependencies and impact that ripple over. But I think within topology protocol, snapshots from different CROs, they are isolated. Another idea is, okay, so imagine a CRO where you have 66% of its voters that can participate in the snapshot agreement, right? And you have 66% deciding to agree on something that is not following the protocol, i.e. they're going Byzantine. But because they're all going Byzantine at the same time, it becomes the decision, it becomes the agreement of that CRO going into the snapshot. Well, one way for this to be managed is you can have the minority be able to exit from the situation, in the sense that maybe you have a previous snapshot where the minority can go back to and essentially fork from there and have a different CRO. It's the same CRO blueprint, as in the code is the same, but you're going back one snapshot ago and starting your state from there. So it becomes two CROs with the same behavior but different states, because the one CRO is compromised by a majority, so the minority decide to exit. Does that make sense?
Yeah, I like the later idea, because like the proposed side, like the attack I propose is something like 1-0 is, and maybe it's controlled by several honest ones and a lot of like malicious ones join it to pollute it. But it makes more sense if we can have some, if we can let the honest one to following the previous, I will say the previous correct state. And each CRO does not influence each other, at least in the topology protocol. I feel like, it's from intuition solves the malicious concentration in several, I will say several CROs or several shards of the entire validators. Yeah.
Right. I think the bad thing here that's maybe you're worried about is, what if a single snapshot can atomically trigger a bunch of transactions on some blockchain that carries a lot of financial value to it? So
exactly.
I don't think we want that. I don't think we want to build a vulnerable system like that.
But here you have two things. One thing is that signaling is going to, not the snapshot itself, but the thing is, signaling might trigger weird stuff with interactions. And the other thing that you were saying about good nodes just fork the version. That is actually true. That is going to happen if bad behavior happens, in the sense that it breaks invariance. If it doesn't break invariance, it's about a valid operation. So no one is doing bad behavior there. That's something that people might have a hard time to grasp it. But the thing is, if I'm a bad actor and I do lots of bad stuff, but I don't break any invariant, for everyone else, I'm not a bad actor. So I can, my bad actions probably are going to be like doing the OS is signing bad stuff. And the thing is, I still can get blacklisted for that, but all the operations that I submitted don't break invariant. So I'm not in that sense, all the operations are included within the CRD, the CR. So I can give you a better example on that. So me as a bad actor, I have two nodes. I have one node that doesn't do anything Byzantine, and one node that does lots of stuff Byzantine. And the thing is, if the bad node, my good node never blacklists my bad node, because they are both my nodes, and I modify them so it's never blacklisted. And the thing is, I can insert all my operations, even with all my Byzantine behavior, because they don't break invariance, and I just send it to the good node, and the good node propagates to everyone, and no one is going to deny it, because it doesn't break invariance.
I see.
I think this belongs to the security topic.
Yeah. No,
and I think we can be
This question involves lots of different topics. That's why this is an interesting question. But the thing is, in the end, this is a security question. But it involves lots of other topics. So it's super interesting. Yeah.
And I think it's worth sitting down and laying out the actual threat model and describing it in detail.
Yeah.
If we want to,
Yeah, sounds good. We can talk more later.
Are you satisfied with the answer?
Yeah. If we give like security assumption, like each CRO does not influence each other, I can understand it. Yeah, as long as one is corrupted or one is compromised, it does not influence other states, or other states does not influence from it. It will be there. It does not influence the system security from intuition. So I can understand it. Yeah.
Nice. So we We have a couple more questions, but they were done by the Topology team, so I'm going to skip them. So we should give the floor to M. Concat. June is here. Yeah,
Oh.
June just arrived. June, do you want to introduce yourself? Come on stage, speak a bit. Listening to you.
Hi.
Hello.
Hello.
1, 2, 3. 1, 2, 3.
Works.
Does it work?
4, 5, 6.
Okay, good. So, yeah. So my name is June. I'm working in the Cosmos space right now, and I have been working on the multiple projects, including Cosmos Hub, Osmosis, and right now in Cosmology. And I have been like a talk and cooperating with the Topology team from last year. Yeah, and I'm really like into the interoperability and the communication between the different independent networks. So, for example, IBC on Cosmos. So Topology, for example, the communication and the real-time RDTs that is working between the distributed node really fascinates me. Thank you.
Hey, love it. So we already ran over 1 hour. So
that's right.
We might wrap up this one.
Sure, let's do it.
Do you have any big questions that are super related with anything from today? Otherwise, we have lots of time in 2 weeks. You should join us.
Yeah, in case in case there's no more question to answer here, we can wrap up. Okay, yes, let's wrap up.
Wait 1 second, because someone sent a message just now. I'm wondering if it's a question or a remark.
Okay.
No, it's an appreciation message. Thank you so much for joining. I really am super thankful, because our community calls have been growing in size since our first one. It's the third one, and we already have lots of new people here, so it's super nice. So yeah, I think we can wrap up.
Yeah, let's wrap
regards.
up.
Let's regard GG.
Telegram.
Thank you, everyone. Bye.
We have a Telegram chat here, Discord and GitHub. Yep. For the curious minds and for the socializing minds, come talk to us and let's work together. Thank you.
Bye, guys. Thank you so much for joining.
Bye. Thank you for coming. Have a good day.